Got to put my favorite student's name on. Good old Ann. A skydiver is in free fall. You know what? I've been in free fall. Have I mentioned lately I jumped out of an airplane? Because I have jumped out of an airplane. I do have a video. We already did. A skydiver is in free fall. She has been falling long enough to hit terminal velocity. Okay. Which of the following statements are true? A, there are no forces acting on the skydiver because she's not accelerating. True or false? How do you know? What are the forces acting on her? Get the obvious one. What else? Air resistance. Okay. The magnitude of the gravitational force is less than the magnitude of the force of air resistance. Not if she's hit terminal velocity. They're the same. The net force on the skydiver is equal to 0. Paige, is the skydiver accelerating? So if you're not accelerating, the forces must be, I'm looking for a word that starts with the letter B, and it means the net force is 0, because MA is 0. Once the skydiver pulls her parachute and starts to slow down, the net force is up. She's moving down, but she's slowing down. Which way is she accelerating then? Which way is the net force then? Hey, this is true. So FFTT. Example 2. Find the acceleration of both masses if there is no friction. Okay, this is a job for a free body diagram. Oh, half mark for each of those for a total of 2 marks, right? I'm going to have M1G.
Hello. He was with me. Don't throw anything at him.
Oh, but I'm so tempted. We're going to have normal force number 1. No friction. Tension. Tension 1 or just tension? This is not a rope. This is just something pulling from off the screen. It could be at someone's hand actually grabbing onto that 15 kilogram mass. So there's not a second tension. What are the forces acting on the 15 kilogram mass? I have M2G. Normal force number 2, which I'm pretty sure is the same size as mass number 2. We have F applied and tension. Who's winning? It looks like it's going to be winner minus loser plus winner. That equals M all A. Mr. Dewick, how come M1G and M2G didn't show up in my equation? Because I'm writing the forces along the rope, and they're not along the rope. Direction matters this year. We have to be very, very careful. Oh, I needed this on a Friday morning. Love it when tension cancels. Mr. Derrick, if I don't write the T's, will I still get full mark? Yes, but I'll always write them because it's a giggle joke that makes me laugh, and I need that when I'm teaching you sorry people, right? Right. Something's got to make me laugh because staring at... Anyway. Darman, how would I get the A by itself? It's going to be F applied divided by, and M all is M1 plus M2. Sloppy mistakes. Every once in a while, I see a kid put a times there. No. If you're adding up the mass, if you want the total mass, you'd add them up. So it's going to be 42 divided by 10 plus 15. It's going to be 42 divided by 25. I should be able to do that in my head, but for some reason my brain can't come up with a clever way to divide by 20. First of all, I've got to type it right. 42 divided by 25. I guess I could divide by 100 and then times by 4. Let's do that. So if I divide by 100, it's 0.42 times by 4. It's going to be, is it 1.68? Hey, I did do it in my head. A little worried. My brain was letting me down there for a second. Getting old. Find the tension. I would use mass 1. Much cleaner. Because if I use mass 1, oh, by the way, for 2 marks, 2 out of 2 if you got the right answer. Otherwise, I would give you a half mark for the original force equation, a half mark for getting the A by itself, a half mark for the numbers, and a half mark for the answer. Find the tension in between both masses. Tension equals M1A. Oh, and I can even do that in my head. It's going to be 10 times 1.68. Is it 16.8 newtons? It better be. You would get the same answer if you used mass 2. You would go F applied minus tension equals M2A. You would swappy dance. You would end up with F applied minus M2A equals tension. and then you would get 16.8. But I would just never do it that way because I'm lazy. In this case, 1 mark, half mark, half mark. And then I would turn the page or next page over. Oh, now we're, ooh! Moving to the right and slowing down. Ooh. Okay. Well, still M1G, normal force 1, tension, but now I guess I got friction force 1. M2G, normal force 2, F applied, tension, ooh, don't forget, friction force 2. Hey, what direction is winning? Left. So who's winning? Anything pointing to the left is going to be positive. I'm actually going to start here and work my way this way. I'm going to end up with friction force number 1 minus tension plus friction force number 2 minus F applied. That equals M all. And you know what? I'd probably even just do this right away almost and say, oh, for Pete's sakes, I'm going to do that. Because then get that by itself. Sorry, lose tension. Let's see. Friction is what times what? I don't know the normal force. Oh, but look. I would probably on my next line go mu M1G plus, not minus, mu M2G minus 42 all over M1 plus M2. That equals A. Then I would probably, right around now, go to the numbers. M1, oh no, mu, what's mu? I don't know, what's mu with you? 0.24 times 10 times 9.8 plus 0.24 times 15 times 9.8 minus 42 all over 10 plus 15. Definitely brackets around the top. 0.24 times 10 times 9.8 plus 0.24 times 15 times 9.8. Take away 42. Close off the top. Did everything type properly there? That looks good. Divided by, open up a bracket, 10 plus 15. Close off the bottom. You get 0.672? So it's barely slowing down, but it is. Meters per second squared. If you got that, 3 out of 3. Otherwise, I would give you 1 mark if I saw that equation, 1 mark if I saw that, half mark for the numbers, and a half mark for the answer. Find tension. I think I'd still use mass 1. It's a little less cluttered. I would go tension minus friction force 1 equals M1A. I would say tension equals M1A plus mu times the normal force. I don't know the normal force. Oh, but look, another force the same size as the normal force. I would say tension equals 10 times 0.672 plus 0.24 times 10 times 9.8. Don't know what that is. 10 times 0.672 plus 0.24 times 10 times 9.8. Any typos, Mr. Dewitt? That looks good. Did you get 30.2? No? Yes? No. Am I wrong? Am I wrong or right? I need someone to nod or shake their head because nobody has moved. So, you ready? Did you get that? Did you get that? You didn't do... Did you get this? Am I wrong or right? Did I make a mistake? Jeez, you guys are a big help.
Tension minus tension equals MA?
I swap... Sorry?
Should it be tension minus friction equals MA? Because friction's winning.
Friction's winning. Wow, I did tension as the winner. Well, that was dumb of me. You gotta respond a little better though if I'm wrong. I make mistakes sometimes on purpose. You're telling me I should have gone, wow, I just slipped into a habit. You're right. It's friction minus tension equals MA. And so it's a swappy dance. It's going to be friction 1 minus M1A equals tension. My goodness, Duick. It's going to be mu M1G minus M1A. That equals tension. Is that what you're saying? It's going to be 0.1. Was it 0.1, Mr. Duick? No, 0.24. Times 10 times 9.8 minus 10 times 0.672. Xavier, you get a candy for being willing to speak up and say, Duick, you're wrong. Didn't do it? Oh. Is it 16.8? Is that better? Now I'm seeing some nods. So, apparently, half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer, and a half mark if you don't just do it wrong like a meathead like I did. Habit. I know, you know what? That's why I switched this question on purpose, is because I thought, let's make sure we're thinking through, right? Ooh, elevator questions. I like riding on elevators. They're fun. It's like climbing stairs, but without the work. I need a free body diagram. You know what? I'm going to do a generic free body diagram because I know the tug of war is between gravity and the normal force. I'll draw them the same size and I'll imagine the arrows getting longer and shorter as needed. I think in physics 12, probably we can get away with that. So we're accelerating up. You know what? Clearly normal force is winning. And they want me to find the scale reading. No, they don't. What do they really want me to find? Or I'll tell you the scale reading and ask you to find the acceleration. That's really what I'll do for elevator questions. They're good conceptual questions, even in Physics 12. I did a bunch of them in Physics 11 with you as well. And also, I'm making the assumption that every one of you has probably been in at least an elevator once in your life. Okay. Normal force is going to be MA plus MG. It's going to be M 75, A 1.6 plus 75 times 9.8. $855? Is that right? People nodding? No, yeah, yeah. Oh, you did that one, did you? Okay. Accelerating downwards. That's going to be mg. Oh, 2 out of 2 for that. Otherwise, again, half mark for that, half mark for getting the normal force by itself, half mark for the numbers, half mark for the answer. You've seen my marking scheme before. Mg minus normal force equals ma. Why did a whole line suddenly move up there? That was a little weird. Okay. Is that 0.5? Let's put it, I don't know, right about there, let's say. Weird. Swappy dance. It's going to be mg minus ma. That equals the normal force. So the normal force is going to be m 75. G 9.8 minus m 75. A 1.25. 75 times 9.8 minus 75 times 1.25. What if instead of asking you for the normal force in newtons, what if I had asked for kilograms divided by 9.8? That's what your scale, your standard bathroom scales actually do. Pause for a second. So I got 641 newtons. Elevator moves up. What's the key phrase actually in this question? Not the elevator moves up, but what? And I used the word moves on purpose because some of you were driving me crazy. You were saying, oh, we're moving in such a, and trying to use Newton's laws. Newton's laws don't help us for motion. They only help us for acceleration. So I would underline that. And then I would say, I guess the normal force just equals mg. It's going to be 75 times 9.8. That's a terribly messy 9.8. You know what, Mr. Dewick? Write it out algebraically because your kids can read your letters better than they can read your numbers. It's going to be 750 take away 15. Is it 735? Yeah. Yes? Do I need to do a proof, or you've learned enough physics now, since the scale measures normal force? If you're standing on it in midair, there is no ground to push up on the scale, so no normal force. Okay? Can you give yourself a lovely score, please, out of 19? If you need to lawyer